a short number using powers of 10. So for the first example, we have 0.00709. If we want to write this as a power of 10, meaning that we're going to have a number coefficient times 10 as a power of 10 with an exponent, okay? When we go to write this, our exponent is going to be how many places we moved our decimal. And this is going to be our number coefficient, which has to be between 1 and 9.9. Okay, so the first thing that we're going to do is we're going to take this longer number and we're going to make it into a shorter version to represent this as a power of 10. So we are going to move our decimal point 3 spaces, 1, 2, 3, to make our number 7.09. We want it to be 7.09 because we want it to be a number that's between 1 and 9.9. That's the only place that I can move the decimal where it would be between a number between 1 and 9.9. So I'm going to write times 10, and then I'm going to put the number as an exponent of how many places I moved. I moved the decimal place 3 times, so I'm going to put 3 as an exponent, and it's going to be negative because this represents a small number. This number is just a shortcut way to write a longer number. All right, for example 2, we have 7,090. And if we wanted to write that in scientific notation, the decimal, as of right now, you can't see it, but the decimal is really at the very end, and that's what makes this number 7,090. So we want to move the decimal place to the left 3 spaces to make this number a number between 1 and 9.9. So if we move it 3 spaces, it would be 7.09, the same as our coefficient in the first example, times 10 to the 3rd power. Now this exponent of 3 is going to be positive because this number right here represents a larger number, not a smaller number. So we're going to keep this as a positive 3, and then the first example was a negative 3 because that represented a smaller number. Okay, the number written in the longer form in each of these examples, this number is called standard form. So these two are written in standard form, meaning they're written long ways. And when they're written with a coefficient as a power of 10, they're written in scientific notation form. Alright, when you multiply and divide in scientific notation, we're going to use the exponent properties. When you multiply the coefficients, you're going to add the exponents. So when you multiply numbers that are written in scientific notation, you're going to multiply the coefficients, the number in front of the multiplication symbol. So we'd multiply those together, and we would get 25.888 times 10, and then we would add the exponents. So we would add 5 and 7 together. So 5 plus 7 would give us 12. And this number right now is not written in scientific notation because this number right here, the coefficient, has to be between 1 and 9.9. So we're going to rearrange the decimal in a little bit to try to figure out how to write that in scientific notation. But first, I'm going to divide the coefficients and subtract the exponents from my next example. So I'm going to divide the coefficients, and that gives me 0.375 times 10, and then I'm going to take the exponents. 7 minus 3 gives me 4. So these are the answers that I come up with when I multiply in scientific notation and when I divide in scientific notation. But I'm going to come back and have to move the decimals because each of these coefficient numbers are not between 1 and 9.9. So when the answer is not between a decimal number 1 and 9.99, like our example 1 was 25.888 times 10 to the 12th power. And example 2 was 0.375 times 10 to the 4th power. So with this coefficient, 25.888, we want to make this a number between 1 and 9.9, so we're going to have to move the decimal place one space to the left to make this number 2.5888 times 10. If you have a bigger number, if you start off with a bigger number, this number is bigger than 9.99999 or 10. This number is bigger. So to make the number smaller, we had to move it to the left, right? So bigger than 9.999. Move the decimal. We moved it left to make it smaller. So you must increase the exponent by how many spaces moved. So for this one, we moved one space to the left in order to make this number smaller. So we have to make this number larger by however many that we moved, however many places we moved the decimal. So 12 plus 1 would give us 13. So this would be our final answer because this number is written in scientific notation. So when you move the decimal to make it smaller, you must increase the exponent by adding the number of spaces that you move. When we did example 2, it was also not in scientific notation form. So the coefficient for example 2 was 0.375. In order to make this number a coefficient between 1 and 9.9, we would have to move the decimal one place over to make 3.75, which is a number between 1 and 9.999. And then times 10. And since we move the decimal place one place to make this number, the coefficient, bigger, we want to make our exponent smaller by the same amount. So since we moved it one place and made the number bigger, we're going to move or subtract 1, because that's the amount of places that we moved, from our exponent to make an exponent of 3. So now this number represents this number, but it's written in scientific notation because the coefficient is between a number of 1 and 9.9. So since the coefficient was smaller than 1, you move the decimal right to make it bigger. So then you must decrease the exponent by however many spaces you moved. So we're decreasing, because we increased the coefficient, we're decreasing the exponent. Just like in example 1, since we made the number smaller, we're going to make the exponent bigger.